Hi everyone! Today, we'll be looking into how to use the Moore Garg Strain Index to assess ergonomic risks or hazards in the workplace. The Strain Index is a method for evaluating the risk of developing musculoskeletal disorders of the distal upper extremity, specifically the elbow, forearm, wrist, and hand. Here is the Moore Garg Strain Index tool. It consists of 6 variables to assess aspects of job tasks, rating criteria, explanation of the criteria, and also the multiplier values. The assessor should remember to take note which extremities are being assessed: the hand, wrist, forearm or elbow, and which side, left or right. The first measure is the intensity of exertion. The intensity of exertion is an estimate of the force required of a task. It reflects the magnitude of muscular effort performed during one cycle of task. We can categorize it to light, which is barely noticeable or relaxed effort; somewhat hard, noticeable of definite effort; hard, obvious effort, unchanged expression; very hard, substantial effort with changed expression; and near maximal, uses shoulder or trunk for force. Take note the rating or multiplier at the rightmost column. Light is scored 1, somewhat hard as 3, hard is 6, very hard as 9, and near maximal is 13. Now, we call these multipliers because the scores for each measure will not be summed up but will be multiplied instead. When we evaluate this measure, please remember that this does not reflect stresses related to endurance or stamina. The second measure is the duration of exertion. The duration of exertion reflects the physiological and biomechanical stresses related to how long an exertion is maintained during a full cycle of tasks. It shall be reported as percentage of time an exertion is applied per cycle. To measure the duration of exertion, we would need to analyze the task being performed. The more cycles of tasks observed, the better the average estimates. Identify the motion or work that constitutes one cycle. Within a cycle, there are periods of exertion and periods of relaxed effort. We will need to identify the duration of the period of exertion per cycle of tasks. This percentage can be calculated. The equation is percentage of duration of exertion equals average duration of exertion in one cycle over average total duration of one cycle times 100. Say we have an average one cycle of tasks lasting 30 seconds, while the average duration or period which the worker applied exertive force is about 5 seconds. We can calculate it as 5 seconds of duration exertion over 30 seconds of total cycle duration times 100 to measure it as percentage, and we'll get 16.7%. In the Moore Garg Index, 16.7% is scored as 1 in the multiplier rating column. For the next measure, we will score or assess the efforts per minute. Basically, how many times effort was required within 1 minute. A full observation of at least 1 minute is required to make an assessment here. The longer the observation, the better we can estimate the average. The fourth measure is the hand or wrist posture. This measure is quite straightforward. It assesses if the work was conducted in the joint's natural position or posture. It is categorized as very good, position in perfectly neutral; good, position in near neutral; fair, position is non-neutral; bad, marked deviation from neutral posture; and very bad, near extreme deviation from neutral posture. The fifth measure is the speed of work. Based on the observation of work done by the worker, we need to determine if the worker is very slow, extremely relaxed pace; slow, taking one's own time; fair, normal speed of motion; fast, rushed but able to keep up; or very fast, rushed and barely or unable to keep up with the work cycle. The last measure is the duration of tasks per day, reported in hours. For this measure, we need to determine how long does a cycle of work continuously last for in a typical work day. For a factory line worker, the cycle of tasks may repeat from the beginning of the day until the designated break or resting interval. If no such interval exists, then it is assumed to continue until the beginning of lunch break. If there is a period of rest or breaks, the effect of strain on the muscles are reset. However, within a typical workday, a worker may have multiple continuous cycles of tasks. Therefore, you may pick the longest continuous cycle duration to be used in this assessment. If this still seems confusing, maybe a little example would help. Here's an example of a simple line worker's job. Mr. N here is working to cap marker pens and setting them aside. Just take a look at this video. Can you notice which movement constitutes one cycle of tasks? How long is one cycle? How many cycles performed per task? Is it very strenuous? If you need another look, feel free to pause this video and scroll back to the beginning of the observation to have a closer look. Done? Okay. So for this example, one cycle of tasks is from when the worker takes a marker pen and a cap from the cup on the right and places the assembled marker pen into the cup on the left. The worker looks quite relaxed in his task, minimal exertion for a very short duration, and based off the video's timestamp, the one cycle is approximately 4 seconds. Thus, we can roughly calculate an average of 15 marker pens per minute. His posture seems neutral and not awkward at all. He seems to take his leisurely time to assemble the pens as well. In terms of duration, he completes the entire cup well within 1 hour. With no other cups full of unassembled pens or marker pens seen, we can assume Mr. N can rest his hands now. Now, let's put that into the strain index and score it. Let's observe and score the wrist for Mr. N's right hand for now. For intensity of exertion, he seems very relaxed with no change of expression. We can score him as light. Duration of exertion. Within the cycle, the exertion can be observed when the worker snaps the cap onto the marker pen. Duration is less than 1 second, but we will just round it up to 1 second. And the total duration of one cycle is about 4 seconds. So 1 divided by 4 times 100 equals 25%. Let's call this as 25% for this measure. Next is effort per minute. Because each cycle only has one instance of effort, and he was able to complete 15 pens within 1 minute, so let's say 15 efforts in 1 minute and score it 2. For posture, seems like a good posture, not awkward at all. We can score it either good or very good here. Both will score 1. Here, we can see the worker is taking his time to do the task. So we can score him slow or very slow here. And here we can see him finishing the task within 1 minute, and then he breaks. Let's assume he has no other task for the day, therefore we can score him under 1 hour. Multiplier score 0.25. Let's multiply the scores to get the index. 1 times 1 times 2 times 1 times 1 times 0.25 equals 0.5. The strain index score is the product of all 6 multipliers. As you can see from this table, those scored below 3 is safe with almost no risk of injury. Those who score between 3 and 5 is uncertain of risk. SI score between 5 to 7 has some risk, while those who score more than 7 is hazardous and is at high risk for injury. Score of more than 5 have been shown to have some association with musculoskeletal disease of the upper extremities. Our first example earlier has a strain index score of 0.5. Therefore, we can say that Mr. N is quite safe with almost no risk of injury. So that is how we use the Moore Garg Strain Index to assess the risk of injury. Do you think you can try assessing repetitive distal upper extremity movements now using this simple tool? Let's try. This is a video of another line worker stapling some papers. Can you try scoring them? We will reveal the answers at the end. Let's say he does this continuously from 9 AM to 5 PM with a 1-hour lunch break at 1 PM. How would you score his right hand? If you need more time, you can pause this video and scroll back to rewatch the second video and assess the strain index again. Take your time.
What you gonna do for it? How you gonna move for it? What you gonna be? And do you believe you can do anything? What you gonna do for it?
Are you done? Let's check the results. Did you get 6 times 1 times 1 times 2 times 1 times 1? It equals 12. Did you get it right? Congratulations if you did. If you had a different result, try going through the entire video again and see if you might have misinterpreted anything. Let's observe and score the wrist for Mr. N's right hand. For intensity of exertion, there was no change of expression but has some obvious effort. We can score him as hard. Duration of exertion. Within the cycle, the exertion can be seen 4 times for a duration of 1 second each when the worker staples the paper on each side. And the total duration of one cycle is about 25 seconds. So 4 divided by 25 times 100 equals 16%. Let's score this as 16% for this measure. Next is effort per cycle. Because each cycle only has 4 instances of effort and it's about 2 cycles per minute, we can say that he demonstrated 8 instances of effort within 1 minute. So let's say 8 efforts in 1 minute and score it 1. For posture, seems like during the stapling process, his posture was not in neutral position, but rather quite markedly deviated. Score 2. Here, we can see the worker is taking his time to do the task, so we can score him fair or slow here. As mentioned earlier, he continues doing his task from 9 to 5 with 1 hour break at 1 PM. So that's 2 continuous cycles of 4 hours. So 4 hours, score is 1. And that is how we get the strain index of 12. That's it for the video today, and we appreciate you watching until the very end. And we hope this video was useful for you. Thank you.